Descartes' rule, we can find the lower bound for the number of imaginary roots. Let us see. P of x is a polynomial of degree n. M is the number of sign changes of P of x, and k is the number of sign changes of P of minus x. Then there will be at least n minus m plus k imaginary roots. That means it's giving the lower bound. There should be at least n minus m plus k, where n is the degree of the polynomial, m is the number of sign changes in P of x, and k is the number of sign changes in P of minus x. Let us make this idea clear with an example. In this example, we have to show that this polynomial equation has got at least 6 imaginary roots. We have to show that there are 6 imaginary roots. Let us use Descartes' rule. So in this, two sign changes, in this given polynomial, there are 2 sign changes, plus, plus, but plus, minus. So here one sign change is there, minus, minus, so there is no sign change, minus, plus. So here there is another sign change. So 2 sign changes are there. So in P of x cannot have more than 2 positive roots. Positive roots cannot be more than 2. Then for getting the maximum number of the negative roots, you get P of minus x. So when you change the sign here, odd power, so it will be minus 9x raised to 9 minus 2. For this x you put minus x. So since it's odd power, it will become minus, but here it is even power. So when you take the 4th power, sign will not change. So here this minus is there. Then minus 7, here x you put to minus x, so minus x square is x square, so minus 7x square plus 2 is 0. So in this there is only one sign change. Here you can see minus plus, so there is only one sign change. So positive roots of this polynomial equation cannot be more than 1. That means negative roots of this polynomial cannot be more than 1. So here 2 and 1. So here degree of the polynomial is 9 minus maximum number of the positive roots is 2. So the m is 2. K, the maximum number of the negative roots, k, that is 1. 1. So 2 plus 1, 3. So 9 minus 3, 6. So there should be at least 6 imaginary roots. So the Descartes' rule is not giving the exact number of positive roots and negative roots. It is giving the maximum or bound, upper bound of the number of positive roots and negative roots. Using the Descartes' rule, let us find the nature of zeros of this polynomial or roots of the polynomial equation. When you equate this to 0, it's a polynomial equation. See the number of sign changes. There is no sign changes. All the terms are positive. So there is no sign change. So the 0 number of sign change is 0. Then as per the Descartes' rule, s minus p should be a non-negative even integer. So p cannot be more than s. S is the number of sign changes, p is the number of positive roots. So it is non-negative. S minus p should be non-negative. That means p cannot be more than s. So s is 0. So p also should be 0. So number of positive root is 0. Next, for getting the number of negative roots of this, you write p of minus x. Since all are even powers, so again it is going to be positive when you take the even power for this x. If you put a minus x and take the even power, again it is going to be positive. So for in this also there is no sign change. So positive roots of this, number of positive roots of this is also 0. That means negative roots of this also 0. So there cannot be negative roots also. That means all the roots of this are imaginary. One more example. Let us use Descartes' rule to find the nature of roots of this polynomial equation. If you equate it to 0, it's a polynomial equation, then number of sign changes plus minus. So here one sign change is there, minus plus. So here another sign change is there. So two sign changes are there, plus plus plus. So after that there is no sign change. So sign change, number of sign change is 2. So the number of positive roots cannot be more than the number of sign changes, because as per this Descartes' rule, s minus p should be non-negative. That means p cannot be more than s. If p is more than s, it will become negative. So it is non-negative. Then one more thing, it should be even integer. So the number of positive roots cannot be more than 2. And s minus p should be even. Okay, now here you see the sign changes, two sign changes. Then sum of the coefficients is 0. 2 plus 5, 7, 7 plus 11, 18 plus 1, 19, 19 minus 19, 0. So sum of the coefficients 0. So x is equal to 1 is a root. So x is equal to 1 is a root. Then number of roots cannot be more than 2 and it should be even also. So suppose we are taking the number of positive roots as 1. So 2 minus 1, 1, but it should be even. So it cannot be 1. So it can, if it is 1, 2 minus 1, 1, it is an odd number, it should be even. Then next then it cannot be 0, because already you know x is equal to 1 is a solution. So number of positive roots cannot be 0. So compulsorily it should be 2. Then only 2 minus 2, 0, 0 can be considered as even. So the number of positive roots is 2. It cannot be 0 because the sum of the coefficients is 0. So x is equal to 1 is a solution. So p cannot be 0. P cannot be 1. If it is 1, 2 minus 1, it will become odd. It should be even. So the next possibility 2. So the number of positive roots 2. Now for getting the number of negative roots, you get a p of minus x. So then here you see the sign changes, minus, 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 plus. So here one sign change is there. So number of sign change in this case is 1. Number of sign change is 1. Then the positive roots will be the same as the negative roots of this. So the number of positive roots of this cannot be more than 1. Similarly, the number of negative roots of this polynomial equation cannot be more than 1. You cannot take a 0. If you take a 0, you will get 1. 1 is not an even integer. So next possibility 1. As per this Descartes theorem, number of the positive roots cannot be more than 1, or the negative roots cannot be more than 1. So the possibility is 0 and 1. If you take 0, you will get 1, but 1 is not an even number, so it cannot be 1. The next possibility is 1. So 1 minus 1 is 0. The number of negative root is 1. So the number of positive root is 2. Number of negative root is 1. Then it is a fifth degree polynomial equation. So 2 plus 1, 3. Then there will be 5 roots, 2 positive roots, 1 negative roots. Then remaining will be imaginary roots. Thank you for watching.